Welcome to Calculus Practice, Integrals of Rational Expressions, or Integration of Partial Fractions. Now, a general note is that I'm not going to point out in each problem, but obviously the functions are not defined where there's a division by zero. The solutions are not defined where there's a natural log of zero. So just be aware of that. The technique that we're going to use is I'm going to give you a problem, 9 of them, and so we would find the integral of x plus 7 over x squared minus 7x plus 10 dx. And I would recommend you go ahead and try it before the video moves on, because the solution comes next. And seeing the solution tends to ruin it for you. That makes you think you can work it. Here we're trying to find out, or you should be finding out, whether you can work it. So the technique is find the denominator of, factor the denominator of x squared minus 7x plus 10 to be x minus 5 times x minus 2. And so we'll rewrite as constant over x minus 5 plus a constant over x minus 2. And what we're going to do is, if we put this back together, we'll find the a and the b. So then we will have two simple integrals. So here a times x minus 2 is ax minus 2a. B times x minus 5 is bx minus 5b. And that will become our numerator if we want to make this a common denominator. And that is equal x plus 7. So we get two equations, the x equation, ax plus bx equals 1x, so a plus b equals 1. And the second equation is negative 2a plus b equals 7. So you now have two equations and two unknowns, the unknowns being a and b. And I recommend you take out your calculator at this point and do a reduced row echelon form and find the answer using matrices. Two equations, two unknowns isn't too much of a bother. Three equations, three unknowns, it's going to be a little bit more of a time consumption, and there's opportunity to make careless error. So having solved this, we find that a equals 4 and b equals negative 3, and we plug them in. So we have the integral of 4 over x minus 5 minus 3 over x minus 2 is 4 times the integral of 1 over x minus 5 dx minus 3, the integral of 1 over x minus 2 dx, of 4 times the natural log of x minus 5 minus 3 times the natural log of x minus 2 plus some constant of integration. Okay, now we're going to find the integral of 2x squared plus 12x plus 5 over x cubed plus x squared minus 4x minus 4 dx. One thing you might remember is, and it's worth being aware of this, calculus is easy. It's having to go back and use any math technique from algebra or trig that you know. So we're going to have to factor x cubed plus 4x squared minus x minus 4. And we would do that by grouping. So we'll take an x squared out of the first two terms. So it's x squared times x plus 4. And we're going to take a negative 1 out of the last two terms. So we get x squared minus 1, factors x plus 1, x minus 1, times x plus 4. So now we have our integral equals 3 fourths a over x plus 1 b over x minus 1, c over x plus 4. So it's going to be a times x minus 1 times x plus 4. So that'll give us ax squared plus 3ax minus 4a. B times x plus 1 over x plus 4 will give us bx squared plus 5bx plus 4b. And c times x plus 1 times x minus 1 will give us cx squared minus c. And we'll set that equal to our numerator, 2x squared plus 12x plus 5. And we find a equals 2, b equals 1, c equals negative 1. So we end up with the integral of 2 over x plus 1 over x minus 1 minus 1 over x plus 4, or 2 times the integral of 1 over x plus 1 dx, which is 2 times the natural log of the absolute value of x plus 1, plus 1 over x minus 1 is integrates as the natural log of the absolute value of x minus 1, minus 1 over x plus 4 is minus the natural log of x plus 4. That's the constant of integration. The third one, this one is a little different. We're going to take the integral of 3x minus 2 over x squared plus 4x plus 4. Here we factor x squared plus 4x plus 4, and we get x plus 2 squared. That's a little different. So we're going to get a over x plus 2 plus b over x plus 2 squared. If we had x plus 2 to the 5th power, we would have a plus b plus c plus d plus e, each over one higher power. We have to account for all the powers. Now, so that's not difficult. Here we're going to find a needs an x plus 2, so it's ax plus 2a. B is fine, so it's plus b equals 3x minus 2. Solving two equations and two unknowns, we get a equals 3, b equals negative 8. So we got the integral of 3 over x plus 2 minus 8 over x plus 2 squared. Well, 3 times the integral of x plus 2 dx is 3 times the logarithm of the absolute value of x plus 2. Here, I let u be x plus 2, and I have u to the negative 2nd power. By the power rule, it goes to u to the negative 1st power, so I get x minus 2, and then I get the negative 1 with the negative 8, so I got 8 over x minus 2 plus c. So don't get into the habit of saying I'm always going to get a logarithm. Number 4, the integral of 3x squared plus x plus 7 over x cubed minus x squared plus 5x minus 5. Again, we're going to use the grouping technique. And so we're going to take x squared times x plus 5 times negative 1. And so we're going to get x squared times x minus 1 plus 5 times x minus 1. Okay, so now we got a square term in the denominator. So we're going to need two constants, ax plus b. over the x squared plus 5 plus c over x minus 1. So we find a, b, and c in this case because we're going to have three equations and three unknowns. The x squared, the x, and the constants. So a is 1, b is 3, and c is 2. So I'm going to get x plus 3 over x squared plus 5 plus 2 over x minus 1. I'm going to break this into two fractions, x over x squared plus 5 plus 3 over x squared plus 5. The first one, I'll let u be x squared plus 5. du is 2x. Well, I'm missing the 2, so that's easy enough to deal with. I'll get a 2 in my dx. I need a 2 in the denominator. Times logarithm of absolute value of x squared plus 5. We really don't need the absolute value since this must be a positive value. 3 over 3 times the integral of 1 over x squared plus 5 is a little different. This is a arctangent. And if you look up arctangent in your table, you can find you're getting 3 arctangent of x over the square root of 5, or square root of 5x over 5. This is simply a natural log, so plus 2, the natural log of x minus 1 plus c. Find the integral of 4x minus 13 over x squared plus 9x minus 10. Here we're going to factor x plus 10 times x minus 1. And so we're going to get an integral of a over x plus 10 dx plus the integral of b over x minus 1 dx. A and b are going to be 3 and 1 respectively. So we're going to get 3 times the integral of 1 over x plus 10 dx plus 1 over x minus 1 dx, or 3, the natural log of the absolute value of x plus 10 plus the absolute value of x minus 1, the log of the absolute value of x minus 1 plus c. Find the integral of 2x plus 11 over x squared plus 11x plus 10. We're going to factor x squared plus 11x plus 10 is x plus 10 times x plus 1. So we're going to have a over the integral of x plus 10, b over the integral of b over x plus 1. If I solve for a and b, I'm going to find a is 1, b is 1, which is nice. So I'm going to end up with the integral of 1 over x plus 10 and the integral of 1 over x plus 1, or the natural log of the absolute value of x plus 10 plus the natural log of the absolute value of x plus 1 plus the constant of integration. Find the integral of 7x minus 26 over x squared minus 7x plus 12. I'm going to factor the denominator as x minus 4 times x minus 3. And I'm going to end up with integral of a over x minus 4 plus the integral of b over x minus 3. So I get, setting the numerators equal, I'm going to find that a equals 2 and b equals 5. So this one is 2 times the integral of 1 over x minus 4 dx plus 5, the integral of x minus 3 dx, or 2 times the natural log of the absolute value of x minus 4 plus 5 times the natural log of x minus 3 plus c. Next one, we're going to find the integral of 3x squared minus 1 over x cubed minus x squared. In fact, the denominator is x squared times x minus 1. And we're going to have the integral of 3x squared minus 1 over x cubed minus x squared. And that will be the integral of a over x plus b over x squared plus c over x minus 1. Well, the x squared is repeated, so I have a over x and b over x squared. Well, I'm going to end up with ax squared minus cx plus bx minus b plus cx squared. I'm sorry, it was ax squared equals 3x squared minus 1. And a, b, and c are 1, 1, and 2 respectively when we integrate. And so we're going to end up with the integral of 1 over x, which is the natural log of the absolute value of x. The integral of 1 over x squared, which is the integral of x to the negative second, which becomes negative x to the negative first, or minus 1 over x. And 2 times the integral of 1 over x minus 1 becomes 2 times the log of x, absolute value of x minus 1 plus c. Find the integral of x squared plus 3x plus 3 over x cubed plus 3x squared plus 3x plus 1. Looking at this one, it might look a little hard to deal with the denominator and factor it, but it's not. Because if we use the binomial theorem or the rational root theorem, we recognize that this is the expansion of x plus 1 cubed. So we got a over x plus 1, the integral of b over x plus 1 squared, and c over x plus 1 cubed. So we're going to find that a equals 1, b equals 1, and c equals 1. And so I'm going to have the integral of 1 over x plus 1, 1 over x plus 1 squared, and 1 over x plus 1 cubed. So that's going to be the natural log of absolute value of x plus 1. Now here, I'm going to let u be x plus 1. So I'm going to have u to negative second. Means I get to negative first power when I integrate. So I'm going to have minus 1 over u, x plus 1. And he has to over to negative third power. So again, I'm going to let u be x plus 1, du is dx. I will get negative 2, 2 in the denominator, and u to the negative second plus c. Well, you never know in calculus what algebraic rule you're going to need. Here we had to recognize a binomial expansion, or we would have been pretty much forced into the rational root theorem, the techniques of just factoring this would be a little bit on the difficult side. It's possible, but it's not something we would want to just do. So every problem is going to have to be dealt with. We don't always get logarithms like here. Sometimes we get off tangents. Think. That's the only thing that will save you is thinking. Um, and I hope if you enjoyed this, you will watch some of my other videos and practice some other integrals. And I would hope you would think about subscribing to the channel. We also had the theory, a video on the theory of the integrals of rational expressions. A whole other video with examples. So thank you.